Let's be real for a second. Transitioning from traditional statistical thinking to set theoretic thinking, it kind of feels like you're suddenly expected to speak an alien language. You spend years, literally years, learning regression, and then suddenly you're told to just throw all of that out the window. Well, welcome to this explainer, where we are stepping into the fascinating and, yeah, sometimes incredibly frustrating world of set theoretic research. We're going to dive into this through a cinematic, comic case, shadowing a brilliant supervisor, Dr. Mira, as she guides a totally overwhelmed PhD student through the complexities of fuzzy set qualitative comparative analysis, or fsQCA. Don't worry, she's going to clear the fog so you can actually survive your next supervision meeting. So right off the bat, our student is completely drowning in formulas, but Dr. Mira, she just bypasses the dense math entirely. She hooks him with one fundamental concept that really frames everything we do in fsQCA. You see, a condition can be important in two very, very different ways. She looks right at her student and asks, is the condition required or is it enough? These two questions are absolutely the bedrock of identifying necessity and sufficiency. Honestly, if you can wrap your head around the difference between these two questions, the entire rest of fsQCA just falls right into place. Take a second to really let those two questions sink in. Seriously, it's going to save you hours of pulling your hair out later on.
Okay, Chapter 1, Unpacking Necessary Conditions. Think of a necessary condition as an absolute bottleneck. It's asking what literally must be present. It's a factor that you are going to find present whenever the outcome occurs. Put simply, the outcome absolutely does not happen without it. Think of it like the toll booth on the highway to your outcome. You simply cannot pass without paying the toll. If you're examining successful startups, for instance, having a product to sell is a necessary condition. You literally can't have a successful business without one, right? Let's ground this in a real business example from Dr. Mira's session. Imagine you're looking at corporate ESG, environmental, social, and governance compliance. High regulatory pressure is a hard requirement. You're just not going to find a highly compliant company that isn't facing some form of pressure from governments or watchdogs. But, and this is the kicker, that regulatory pressure alone won't magically guarantee strong ESG performance. It's required for sure, but it is not enough on its own. Other crucial factors, like maybe internal resources or visionary leadership, they've got to be in the mix too. This beautifully illustrates the underlying set logic. In the language of set theory, a necessary condition means the outcome is actually a subset of the condition. Picture a classic Venn diagram. The circle representing your outcome is completely 100% engulfed by the much larger circle representing the condition. Because the condition is a superset, every single time you see the outcome, you are inherently inside the condition's boundaries. It's a non-negotiable prerequisite, no exceptions. Moving on to Chapter 2, Understanding Sufficient Conditions.
Okay, so if necessity is about what's required, sufficiency is all about what is enough. If a condition or a specific combination of conditions is sufficient, its mere presence guarantees the outcome is going to happen. As Dr. Mira tells her student, when you have this, you will always get the outcome. Now, this doesn't mean it's the only way to get there. There could be multiple different paths, which brings in that fantastic concept of equifinality. Equifinality essentially just means there's more than one way to arrive at your outcome. But this specific path, it's definitely enough to produce your result.
And because QCA totally embraces complex causality, sufficiency usually isn't just one single magic factor. It's a configuration, a recipe. A perfect example here is technology adoption. To guarantee successful adoption, you might need a really specific configuration, high leadership support, and high digital capability, and strong training support. When all three of these ingredients show up together, boom, it creates a sufficient recipe for success. It is enough. If even one of those is missing, the recipe might completely flop, but together, they are a guaranteed lock. Now here, the set logic is entirely flipped on its head. For a sufficient condition, the condition or the recipe becomes a subset of the overall outcome. If we draw that Venn diagram again, the circle representing your specific tech adoption recipe is now completely swallowed up inside the larger circle representing successful outcomes. Any case that falls into that recipe circle automatically, without fail, falls into the success circle. Chapter 3, Reading the XY Plots. Visualizing this helps so much. Dr. Mira pulls up this XY plot on her dashboard to show the student. We always plot the condition membership on the x-axis and the outcome membership on the y-axis. Now, notice that diagonal line running straight from the bottom left to the top right? It is absolutely crucial to remember that this line is not a regression line. Scratch that whole idea. You aren't looking for a line of best fit here. Instead, it's a strict boundary of set membership. It represents the precise points where the score on the x-axis perfectly equals the score on the y-axis. And this shows us exactly where real-world cases fall. Each little dot is a case, a company, a country, a person, whatever you're studying. For a condition to be sufficient, visually, the dots must lie on or above that diagonal line, hanging out in that upper left triangle. This means the condition score doesn't exceed the outcome score. Conversely, for a condition to be necessary, the dots will cluster on or below the diagonal line, down in the lower right triangle. It's just this incredibly fast, powerful visual check of your data that instantly tells you if you're looking at a requirement or a recipe.
Chapter 4, Consistency, Coverage, and Sequence.
All right, so the absolutely crucial point here is the sequence of your workflow. You must strictly follow this order. Always test and clear out your necessary conditions before building a truth table for sufficiency. Why? Well, because if you have a necessary bottleneck condition, it's going to be present in every single successful configuration anyway. Ignoring necessity and jumping straight to the truth table, that's a classic rookie mistake, and it can completely undermine your entire analysis. It is exactly the kind of methodological error that reviewer 2 is going to spot immediately and use to reject your paper. No one wants that. Of course, we all know real-world data is messy. Not every dot is going to perfectly obey our nice diagonal line rules. That's exactly why we use consistency scores, to see how closely our cases actually follow the set theoretic rules. Because asserting necessity is such a huge, strong, absolute claim, you're saying something is strictly required, it demands a very high consistency threshold. We're talking 0.90 or above. Sufficiency, while still rigorous, is generally evaluated at a slightly more forgiving threshold of 0.80 or above. Hitting these marks is how you actually prove your findings aren't just random flukes.
But hold on, consistency isn't the whole story. A rule can be perfectly consistent, but completely trivial. Like, think about it. It is absolutely necessary for a company to have oxygen in the building for employees to perform well, right? That is a highly consistent necessity, but come on, that's hardly a groundbreaking finding you can publish. That's why we pair consistency with coverage. Coverage proves empirical relevance by showing exactly how much of the outcome your condition actually explains in your dataset. High consistency proves the rule exists, but high coverage, that proves the rule actually matters.
Finally, Chapter 5, Writing Your QCA Results. As we wrap up this intense supervision session, Dr. Mira provides the ultimate survival tip for academic writing. The student drafts a conclusion. Therefore, digital capability has a positive effect on tech adoption. Dr. Mira stops him immediately. No way. Never, ever use linear regression phrases like positive effect, impacts, or correlates with in fsQCA. It is a completely different paradigm. Journal reviewers will literally tear your manuscript apart if you mix these up. You must explicitly use set theoretic language. You write, condition X is necessary for outcome Y, or the configuration is sufficient. You absolutely have to respect the method in your vocabulary if you want to pass your defense.
Dr. Mira closes her laptop, leaving her student and us with this defining thought. The crucial takeaway from today's explainer is just this. Know exactly which question you are asking of your data. Are you looking for the absolute bottlenecks, or are you looking for the winning recipes? As you look at your own research, ask yourself, have you been confusing what is strictly required with what is simply enough?